and today we are going to be learning how to graph trig equations. Now, how I do them, I do it kind of different from many books that do them. I don't like decimals when I'm putting in my trig function. Now, first things first, to understand how to do this, let's review the unit circle. So what I call the four corners of the unit circle, yes, they're not corners, but it's the best way I can describe it. So if we do the unit circle up here, okay, you have 0, pi over 2, pi, 3 pi over 2. And if you're not familiar with radians yet, you need to get familiar with them because the books will use radians, okay, and 2 pi. Okay, let's go over our exact values. So we're going to have 1, 0 here, 0, 1, negative 1, 0, 0, negative 1, and of course 2 pi is the same thing. Okay, so this is for, remember that cosine corresponds to the x value. So cosine of 0 would be 1, cosine of 3 pi over 2 would be 0, sine of 0 would be 0, and sine of 3 pi over 2 would be negative 1. Sine corresponds to y coordinates, okay? So when you're graphing trig functions, so this is going to be how your coordinate axis is going to be. So your angles are going to be here, and your real numbers are going to be here. So those are going to be your exact values, okay? So when we're doing these, we're going to be ranging from like 1 to negative 1, okay? This side of the graph is where, if you're going, is the negative angles, okay? So if this was negative pi over 4, negative pi over 2, pi over 4, pi over 2, okay? So negative angles, remember, that's just going clockwise around the unit circle, where positive angles go clockwise around the unit circle, okay? So this is kind of how you the setup of a graph looks like. Okay, so let's start first with our basic functions. Let's look at sine. Okay, so we're going to be looking at f of x equals sine x. You could also do y sine x, or you could do sine theta, okay, if that makes more sense, okay? Yes, let's actually go ahead and do that so we don't have to worry about any confusion. So we're going to have y equals sine of theta, okay? X would work too. So sine is going to have a domain of negative infinity to positive infinity. Okay, so it can be any angle. There's no vertical asymptotes. There's no condition saying sine can't be anything, okay? The range, as you will see after we graph it, is going to go from negative 1 to 1. Because as you can see on the unit circle, sine does not go lower than negative 1. It doesn't go higher than 1, so you don't see any 2's. Okay, square root of 3 over 2 is, oops, sorry. Sine of square root of 3 over 2 is, I'm pretty sure, 0.86. So let me do that really fast in the calculator. Okay. Okay, so we got square root 3 divided by 2. Okay, 0.8666. Okay, so everything's going to be lower than 1. Not on the four corners. Okay, so let's go ahead and get started graphing sine. Okay, so first let's set up our table of contents. So we're going to have theta, a theta value, and then we're going to have sine theta. Now, these points that I'm going to be putting down, I'm going to be calling key points. So this is usually where you want to start. Yes, the graph is going to be continuous because the domain is negative infinity to positive infinity, but this gives you a good start to your trig function. So you get 5 points. It's going to be 5 points for each of the trig functions as well, okay? They're not all going to be the same key points, but most of them will be the same. So we're going to do just going around the four corners, okay, as we see here. So 0, we're going to start at 0. Okay, so we have 0. Sine of 0 is 0. Okay, pi over 2. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. So these are your 5 key points. So let's go ahead and graph it over here. Okay. So we'll have 1 here, -1 down here. Pi over 2, pi, 3 pi over 2, 2 pi. Okay, so sine of 0 is 0, pi over 2 is 1, pi is 0, 3 pi over 2 is -1, 2 pi is 0. Okay, so this is the start of it. Okay, you can put this in your calculator, but as a math teacher myself, I appreciate algebra and doing everything, which you will see later. Okay, so it would only help you to know how to do this without a calculator. My motto for calculators, they're there to confirm, and that's pretty much it. Okay, so this keeps going, and it could keep going for as long as we want it to. So for instance, if we wanted to make the graph bigger, so this is one cycle. This is one time around the unit circle, okay? But it's a continuous function because the domain is negative infinity and positive infinity. So if we keep going, we're going to have, let's see, so we have 135 pi over 2. 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. So this would be known as 2 cycles, okay? So you just keep going. So this is going to be 1, 0, -1, 4. Okay, that's 2 cycles. Now how you make it 3 cycles? Easiest thing to do would just be mirror this, the black right here, and just make it negative. So you're going to have, I'm not going to have enough room here, but you'll get the idea, negative pi over 2, negative pi, negative 3 pi over 2. Okay? And sine is also an odd function. Odd functions mean they are symmetric about the origin. Okay? So that pretty much just means if you have a positive y, you're going to have a negative y over here. Okay? So, here we go. Right here. Okay? So that right there is 3 cycles of the sine function. Okay, so let's go to its reciprocal function, cosecant. Okay, so cosecant, the key points for cosecant are going to be the same for sine. The only difference is cosecant, the difference between cosecant and sine is the domain is going to be different, okay? So the domain for cosecant, there's going to be a condition. So wherever sine is 0, there's a vertical asymptote because this is 0 over 1 because sine is equal to y over r equals 1. So if you do 0 over 1, that's 0. But if you do 1 over 0, that's going to be undefined. So where we see those undefineds, there's going to be vertical asymptotes. And they happen at the pi's, okay? So the domain, I'm going to do it in set notation, which is the domain is x such that x can equal number times pi. Okay, and of course n has to be an integer number. Okay, the range. Okay, you're going to see the range here. It's going to be negative infinity to -1 union 1 to infinity. So the range for a cosecant it never crosses the horizontal axis here. It's either going up or down. Okay, so let's go ahead and go through this. So we have cosecant of 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cosecant of 0, that's a type of pi, so 0 times pi, that's going to be a vertical asymptote there. Okay, cosecant of pi over 2 is 1 over 1, which is 1. Cosecant of pi is a vertical asymptote. Okay, cosecant of 3 pi over 2 is negative 1. And cosecant of 2 pi is a vertical asymptote. Okay, now you can also graph this on the sine graph, but I'm just going to graph it by itself here, and then I'll show you what it looks like on the sine graph. And the same conditions apply. I'm just doing one cycle. 2 cycles would be, you're going to see like 4 of them. Okay, so I'm just going to do one cycle here. So we have pi over 2, pi, 3 pi over 2, 2 pi. Okay, let's draw our vertical asymptotes. I'm going to do those in pink. So we have a vertical asymptote at 0, pi, 2 pi. Okay, and how you do this? So here's 1 right here. Here's negative 1 right there. Cosecant of pi over 2 is 1. Okay, and then you just kind of go along the lines of the vertical asymptotes like that. Okay, cosecant of 3 pi over 2 is negative 1. And you just kind of drift along the vertical asymptotes like that. Okay, so 2 cycles would be 1 right here, 1 right there. 3 cycles would be 1 right here and 1 over there. Okay, you could also do these with a sine function. If you get a cosecant, you could go ahead and make it a sine, graph the sine, and everywhere it's going up, it's going to be either up or down. So you got a vertical asymptote here, vertical asymptote here, vertical asymptote here. Okay, so wherever you see a max or min of sine, you can just go ahead and put a parabola looking thing there. So it goes smiley and unhappy, and then smiley and then unhappy. Okay, so anywhere you see a max or min, that's what's going to happen. Okay, so that's how that's the basic graphs for sine and cosecant. Okay, so now we're going to go to cosine. Cosine, excuse me, looks like sine. The only difference is it's a translation. If you remember, translations are left, right, up, and down movements of the graph. The sine function is just a translation, horizontal translation by pi over 2 units. Okay, so let's go ahead and get started for cosine. So we have y equals cosine of theta. The domain is going to be the same as sine. So negative infinity to positive infinity. The range is going to be also the same as sine, which is going to be negative 1 to 1. Okay. So we're going to have theta and cosine of theta. 5 key points, the same as sine, are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, the cosine of 0 is 1, the cosine of pi over 2 is 0, the cosine of pi is negative 1, cosine of 3 pi over 2 is 0, and the cosine of 2 pi is 1. Okay, so here's what the graph is going to look like. Okay, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we start at 1, 0, -1, 0, here. Okay, and remember these are continuous. If you want to do another cycle, a little bit over here, you can do negative pi over 2, negative pi, we'll just go there, okay? And then negative 3 pi over 2. Okay, cosine is an even function, which means it's symmetric about the y-axis, which means if you go to a negative x, your y is going to remain positive. If it was negative down here, your y is going to remain negative. So it's a mirror image over the vertical axis here. Okay, so if it's 0 here, it's 0 there. If it's -1 at pi, it's going to be -1 at negative pi. If it's 0 at 3 pi over 2, it's going to be 0 at negative 3 pi over 2. Okay. Okay, so that's the graph of cosine. Okay, now let's do its reciprocal function, which is secant. Okay, so secant is the same domain as cosecant. So never mind, it's not the same domain, but it's the same type of scenario. So where cosine is 0, cosecant is going to be a vertical asymptote. Okay, so let's see, 1 2 3 4, I'll just have to crunch the numbers there. So we have theta, and then we have cosecant theta. So my domain in set notation is going to be all x such that x can't equal a number times pi over 2. And my range will be the same as cosecant. It's going to look the same, it's just going to be a translation. Okay, just like cosine is the sine. So this is going to be negative infinity to -1, brackets because it's a defined point, union 1 to infinity. Okay, so we're going to have, and for cosecant, I'm going to start at negative pi over 2, because if I don't, I'm going to have like this, and then I'm going to have another half one like this. I would rather just see the whole thing, like a smiley and a frowny, not a half smile and not a half frown. Okay, so I'm going to start at negative pi over 2 here. So that's going to be negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. Okay, so cosecant, so any pi over 2 is going to be a vertical asymptote. Okay, cosecant of 0 is the same as cosine, which is 1. Cosecant of pi over 2 is a vertical asymptote. At pi, it's -1. And at 3 pi over 2, it's a vertical asymptote. You only need 5 points here, 1, 2, 3, 4, 5, to make one cycle of the graph, okay? So let me go back to a unit circle. So we are still doing one cycle. So instead of starting here and around here, we are starting so clockwise this way, and then we're going around like that. Okay. Okay. So negative pi over 2, pi over 2, pi, 3 pi over 2. Okay, so vertical asymptote here, here, and here. Okay. These are supposed to be evenly apart. Okay, just wanted to make that clear. So cosecant as 0 is 1, so it's going to do the same thing as this is secant, my apologies, it should be secant of theta. I don't know why I put cosecant there. Okay, so this is going to look like this. Okay, so that is one cycle of the secant function. Okay, I guess I put cosecant because I kept talking about it right here. Okay. So there you go. So as you can see, if we start at 0, we would have a half one here, and then it would go this, and then it would be like another one like this. That would happen if we went to 2 pi. It would look like that. Okay, so you can start wherever you want to. I just like to see a whole graph look like this. Okay, so now we're going to go to another function, which is tangent. So let's look at our unit circle for tangent really fast. Okay, so tangent is sine over cosine. So when we do our unit circle here, the only difference for tangent, one cycle is 0 to pi. Okay, so that's what we're going to be looking at. So we're going to be adding pi over 4 and 3 pi over 4 there. So we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. So the period of a tangent function is pi. Same with cotangent, its period is also pi. Secant, cosecant, sine, and cosine all have a period of 2 pi. Okay? So let's go through this really quick. So we have 1, 0. So 0 over 1 is 0. Square root of 2 over 2, square root of 2 over 2. So tangent of that is going to be square root of 2 over square root of 2, which is 1. Then we're going to have 0, 1, 1 over 0. That is a vertical asymptote or undefined. Here we're going to have negative square root of 2, square root of 2, square root of 2 over negative square root of 2 is negative 1. And then you have negative 1, 0. So 0 over negative 1 is a 0. Okay? So that's how you're going to do one cycle on the tangent. Okay? So anywhere you see a pi over 2, that's where tangent is going to have a vertical asymptote. Okay? So when we do tangent, let's go over the domain of tangent first. So we're going to have y equals tangent of theta. So my domain of tangent is going to be all x such that x can't equal a pi over 2. Okay? And the range is going to be all real numbers. Okay? So the domain is all numbers such that x can't equal pi over 2. Okay? A number times pi over 2. Okay? Alright, so let's go ahead and get started. So, theta, tangent, theta. So, for this, we're going to start at negative pi over 2. Okay, I guess I should have put that here. So, this is going to be negative pi over 4. It's going to be negative pi over 2. It's going to be negative 1. And then this is going to be a vertical asymptote here. Okay, so we're going from negative pi over 2 to pi over 2. So, negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Okay, so tangent of negative pi over 2 is a vertical asymptote. Tangent of pi over 4 is negative 1. Tangent of 0 is 0. Tangent of pi over 4 is 1. Tangent of pi over 2 is a vertical asymptote. And if you want to keep going, you can. But we're just going to be doing one cycle. So that's a cycle is a period of the trig function you're doing, and the period of tangent is pi. So this is going pi. Okay. And since we did these points, I'll just keep going. Okay, so every pi over 4, that's going to be kind of your distance. So if that's pi over 2 right here. So anywhere there's a pi over 2, draw a vertical asymptote. Okay. So tangent of negative pi over 4 is negative 1. Tangent of 0 is 0. Tangent of pi over 4 is 1. So it's going to kind of look something like this. Okay. And if you do it again, you can. I'm just missing 3 pi over 2 here. So that's 1 cycle. This would be 2 cycles. So 3 pi over 2, that's going to be negative 1. Pi is 0. And then I forgot about 1,355 pi over 4. So something like that. Okay, so that's 2 cycles of tangent. So cotangent is the same as tangent. It's just a little, it's the opposite direction. And you can start at 0 here. Remember the period is still pi. So let's do cotangent. So also unlike cosecant and secant where you can kind of graph along with its reciprocal, you can't do that with cotangent. Cotangent is the other direction and it's a translation. Okay, so let's get started for cotangent. So y equals cotangent of theta. My domain is going to be all x such that x can't equal n pi. Okay, and my range is going to be the same as tangent, so that's going to be negative infinity to positive infinity. Okay, so let's do our key points for cotangent, which is going to be 0, pi over 4, pi over 2, 3 pi over 4, and pi. So that's 1 cycle for cotangent, okay? So cotangent of 0 is going to be a vertical asymptote. The best thing about cotangent and tangent, they keep the same exact values. When you do that, the only difference is the vertical asymptotes are different and the zeros. So cotangent of pi over 4 is 1. Cotangent of pi over 2 is 0. Because now we're doing x over y, so 0 over 1 is 0. 3 pi over 2 is going to be negative 1, and this is going to be a vertical asymptote. Okay, so you have pi over 4, pi over 2, 3 pi over 4, and 2 pi. Pi, my bad. So vertical asymptote here and here. This is negative 1. That's 1. Pi over 4 is going to be 1. Pi over 2 is going to be 0. 3 pi over 4 is going to be negative 1. So it looks something like this. Okay, so opposite direction starts at 0. So I'll show you a better typed picture of what these graphs looks like. Okay, so here's sine, starts like right here. Okay, there's cosine, so the only difference is it's just a movement to the left, pi over 2 units to the left. Here's tangent. Okay. Okay. So I went ahead and drew in the sine graph here, as you can see, but if that wasn't there, it would look like this. And same thing with cosine, I went ahead and drew it in there, but you could just look at it like this. So that's actually like a period and a half for secant. Okay? And then you have cotangent, which looks like that. So that's 1, 2, 3, and a half cycles right there of cotangent. Okay, so now we're going to talk about amplitude and period and all that. Okay, so let's first look at these translations. So just like in normal functions, you have translations for trig functions. Like if you had x minus 1, if you have x minus 1 squared, that shifts the parent graph of x squared to the right 1 unit. Well, trig has the same thing, okay? So there's 4 things you have to consider here. Okay, so we have, so this works for any secant, cosecant, sine or cosine graph. So y equals a sine of bx minus c plus d. Okay, so a is going to be the amplitude. That's the absolute value of a is the amplitude. Okay, amplitude is crest to crest on the graph. Okay, so here you can see the amplitude is 1, or for this one. So it's at 1 and then it's also 1. So this is crest to crest. My amplitude is 1. So it's 1 unit from the horizontal axis this way, and then it's 1 unit from the horizontal axis that way. That's the amplitude. So if it was 2, it would be 2 units up this way and then 2 units down there that way. Okay, and then we have the period. So the period of the graph is going to be 2 pi over b. Okay, and then we have the phase shift, which is going to be c over b. So c over b, remember if it's negative, that's a right unit, so that's not negative c over b, that is just c over b. Now if this was bx plus c, then that would be negative c over b, okay? So if it's just whatever in parentheses is still horizontal movement, okay? You might want to look at your other notes on translations on graph, and you can see they all make the same pattern. Okay, so that's just c over b. So that's a horizontal movement. And then D is a vertical shift. So this is going to tell you if you're going to go up D units or if it was a subtraction sign, down D units. So vertical shift is going to be D. Okay. So that's how you determine all of those. Okay. So how I do these, so I can always have my nice numbers, vertical asymptote, 1, 0, negative 1 type thing. I set bx minus c equal to each key point. Theta. Okay? So if I was doing sine, I would do bx minus c equals 0, solve for x, plug it in, bx minus c equals pi over 2, solve for x, plug it into the sine function that was given. So key point theta, then solve for x, right here, and then you're going to evaluate the trig function, and then evaluate your given information. Your given trig function. Okay, so it's going to be a good idea for you to be familiar with your key points. Okay, so let's start with this one right here. Okay. Okay, so I'm going to start a little bit easy. Let's just start with y equals cosine, or we'll do a negative. Oh, if there's a negative in front of the phase shift, same thing. It's just a reflection about the x-axis. Okay, so this is a reflection. over the x-axis. So let's do y equals -2 cosine of, let's do 3x. Okay? Don't worry, I will explain to you how to check this in your calculator as well. Okay, so the first thing I'm going to do, well, let's go over what we just learned. So for this one, there's going to be a reflection about the x-axis. Okay, the amplitude's going to be 2. Okay, so reflection over x. The amplitude is going to be 2. The period is going to be 2 pi over 3. Okay, so 2 pi over b, whatever's in front of the x, that's b. My phase shift is c over b. Well, I don't have a c, so that's 0. So 0 over 3 is 0. So there is a 0 phase shift, and there's no vertical shift as well. Okay, so how I'm going to do this, I'm going to set whatever is after the trig function here equal to the key points. So you're going to have 3x equals 0. Okay. Solve for x. So this is how you get your x value. This is how you're going to get your y value over here. Okay, that's how you're going to get your y value. So you're going to, this is a table of values. So solve for x, x divided by, or 3 divided by 0 is 0. Now put that in here. So where you see x in here, you're going to put 0. So that's going to be, so y is going to be -2 cosine of 3 times 0. So then you're going to have equals -2 cosine of 0. Cosine of 0 is what? It's 1, okay? Alright, so cosine of 0 is 1. So that's going to be -2 times 1, which is -2. Okay? Cosine is either going to be 0 or 1 right here. So you're going to get nice, neat values when you come out. So this is the reason why I do the key points. So my first point is going to be at 0, -2. Okay? So next one is going to be 3x equals pi over 2. Okay? So divide by 3, or you can multiply by the reciprocal of 3. So times 1/3. So times 1/3 and then times 1/3. It's just easier to see that way. So my x value here is going to be pi over 6. Okay? Now I'm going to put that in the y. And my next key point is actually going to be pi over 2, and you're going to see that in here, or right here, it's going to turn into pi over 2. Okay? So -2 cosine of 3 times pi over 6. Okay? This is when you got to get really good at fractions. Okay? So 3 pi over 6 is going to be 3 pi over 2. And at that point, you can say, okay, so the cosine of 3 pi over 2 is going to be 0. Okay, so you don't have to write all this work. I'm just showing it to you algebraically so you can see it all happen. Cosine of pi over 2. So cosine of pi over 2 is 0. So that's going to be 0. So you got a point at pi over 2, or pi over 6, 0. That's your x, that's your value. Okay. Okay, next one is going to be pi. I'm going to go through this one really fast. So 3x equals pi. Solve for x by dividing by 3. So that's going to be x equals pi over 3. Go here, you're going to have y equals -2. Now if you remember in cosine, your next key point is going to turn into pi. And you're going to see this value that you're going to see right here is going to turn into pi. Cosine of 3 times pi over 3. Okay, 3's cancel out, you're left with pi. Cosine of pi is -1. -1 times -2 is +2. Okay. 2 more points. 3x equals 3 pi over 2. Every time you have a fraction, I just multiply by the reciprocal. So you can do times 1/3 times 1/3. Okay, 3's cancel out. You're going to have x equals pi over 2. Put it in here. -2 cosine of 3 times pi over 2. Okay, so remember the next corner after pi is going to be 3 pi over 2. Cosine of 3 pi over 2 is 0. 0 times -2 is 0. So you have pi over 2, 0. And then you have 3x equals 2 pi. So x equals 2 pi over 3. Okay, I want you to also notice the period was 2 pi over 3, and it automatically brings you to that. Okay? Put it in here. So right here, or right when I get here, should be 2 pi, and you will see that happening. So the reason why I'm doing this, because every single time you get a number, you're not going to get an ongoing decimal right here, okay? So you don't have to guess that. This is already hard with the radians, especially if you first learn this. So this gives you a nice, neat answer that you don't have to worry about any decimals for. Okay, so we're going to have y equals -2 cosine of 3 times 2 pi over 3. Okay, 3 times 2 pi over 3. Remember, that's like a 3 over 1, so that cancels out. Cosine of 2 pi is 1. 1 times -2 is -2. Okay, now this is one cycle. I'll show you how to do multiple cycles as well. The easiest thing here would be to do is go to for the negative angles. Okay. Okay, so write your points. You got 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. Okay. Here's 2. Here's -2. Okay, so you have 0, -2, pi over 6, 0, pi over 3, 2. Oops, this is -2. Sorry. Just ignore that. Pi over 3, 2. Pi over 2, 0. 2 pi over 3, -2. Okay. So this would be one cycle. If you want to do 2 cycles, easiest thing to do is go the opposite way, okay? So just mimic these. So -pi over 6, and since it's even, all the y's are going to be the same value. Pi over 3, pi over 2, -pi over 2, and 2 pi over 3. Okay, so at pi over 6, it's 0. At pi over 3, it's 2. At -pi over 2, it's 0. And at 2 pi over 3, it's -2. Okay? Okay, that's 2 cycles. So let's do 3. 3 might be a little bit, might have to do a little bit of adding. Okay, so you see 0 to pi over 6. So you're gonna be adding pi over 6 to. Okay, so you have 2 pi over 3 plus pi over 6. Okay, you need a common denominator, so you're gonna multiply this by 2. So okay, so that's going to turn into 4 pi over 6. 4 pi plus pi is 5 pi over 6. Okay, 5 pi over 6 plus pi over 6 is 6 pi over 6, which is going to be pi. Okay, pi, since I'm adding pi over 6, I'm just going to go ahead and make that into the same denominator. So the same denominator between 6 and 1 is 6. So you're going to have 6 pi over 6 plus pi over 6 is going to give you 7 pi over 6. Plus pi over 6, which is 8 pi over 6, which turns into 4 pi over 3. Okay, so that's 1, 2, 3, 4. That should be good. So pi over 6 is going to be 0. So you're right here, so just keep following the graph. So now you're going to go there. Okay, now you're going to go up here, and down there, and then down there. Okay, so I was able to show you 3 cycles here. Let me show you in the calculator. Okay, when you're doing this in the calculator, make sure you are in radian mode. Let me try to get it away from the light so you can see it a little bit better. Okay. Make sure you're in radian mode. So to do that, you go to mode. Okay, and I'm already in radian mode. Now you go to y equals, our function was -2 cosine of 3x. Okay, let's graph. And let me turn my grid locks off. Okay, so that's a little better. Okay, so I can check my points. So let's check 0. So if I do 0, I should get 2. So hit trace and hit 0. Okay, 0, -2. Pi over 6. Oops. Okay, 0. Pi over 3 is going to be 2. Okay, pi over 2 is going to be 0. 2 pi over 3 will be -2. Okay, so this way you don't have to do with weird answers. Okay, so you see all these decimals that you would have to do. That's why I do that the way we do. Okay, so let's go to a little more complicated one. Excuse me. Okay, so let's do one where there's a phase shift involved. Okay, just a little bit right here. Okay. Okay, I guess I can't really get it to where it was. I'll try it. Okay, so we're gonna have y equals 2 sine of 4x plus pi plus 3. Okay, amplitude. So there's no reflection here because there's no negative sign. So my amplitude is going to be 2. My period is going to be 2 pi over 4. B is always a number directly in front of the x. So 2 pi over 4 equals pi over 2. Okay, my phase shift is going to be negative pi over 4. Okay, it's negative because it's a plus right here. So this is meaning the graph is shifting to the left pi over 4 units. Okay, and then we have a vertical shift of positive 3. Okay, so the graph is going to be shifting up 3 units. Okay, so let's get started. Same process happens. Whatever is directly after the trig function is what I'm going to set to each of the key points. Now the key points for sine are the 4 corners of the unit circle, which is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so let's get started. So this is going to be our x column. This is going to be our y column over here. So that's going to be y equals 2 sine of 4x plus pi plus 3. And you're going to see it's going to work the same thing out, because once we solve each of the key points for this value, we're going to get in this parentheses 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that's going to give us a nice neat y value when we come out. Okay, so you got 4x plus pi equals 0. So that's going to give you x equals negative pi over 4. Great, that actually matches our phase shift. Okay, so that's where we're starting. Okay, so your y value, and this is going to be a lot easier if you're really good at adding fractions. Okay, so 2 sine of 4 times pi over 4. So where's the x? I'm going to put negative pi over 4 because that's my x value right there. Plus pi plus 3. Okay, 4 times negative pi over 4 is going to be negative pi. Notice whatever you're setting it equal to here, that's what it's going to be here. Okay, so that's going to be sine of 0, which is 0. 0 times 2 is 0. 0 plus 3 is 3. Okay. So then you have 4x plus pi equals pi over 2. Okay. So you're going to have 4x equal to pi over 2. You're subtracting pi, so that's going to be minus 2 pi over 2. Okay, 2 pi over 2 is pi. 4x equals pi minus 2 pi over 2, which is going to be negative pi over 2. Multiply by the reciprocal of 4, which is 1/4. So you're going to be, x is going to be negative pi over 8. Y is going to be 2 sine of 4x, so 4 times negative pi over 8, plus pi plus 3. Now, as a teacher, I would at least want to see this, okay? For a student to help you understand, but I would keep going just in case you got this wrong. So this, if you do not get pi over 2 here, you did it wrong, okay? So 2 sine of, let's see, that's going to be 4 pi over 8, which is going to be negative pi over 2, plus pi, so that's going to be plus 2 pi over 2, plus 3. Negative pi plus 2 pi is pi over 2. Sine of pi over 2 is 1. 1 times 2 is 2. 2 plus 3 is 5. Okay. Okay, next key point is pi. 4x plus pi equals pi. Subtract pi, so you're going to get 4x equals 0, so x equals 0. So y equals 2 sine of 4 times 0 plus pi plus 3. 0 plus pi is, what a surprise, pi. Sine of pi is 0. Hold on, did I do something wrong? Never mind. Wait. 1 times 2. Okay, good. So pi, sine of pi is 0, 2, so plus 3. So y equals 3. Okay. Okay, keep going. 4x plus pi is equal to 3 pi over 2. Okay, so 4x equals 3 pi over 2 minus 2 pi over 2, which is pi over 2, divided by 4, that's going to be pi over 8. If you're not sure what I did, just look at this one right here. Okay, so y equals 2 sine of 4 times pi over 8 plus pi plus 3. So pi over 2 plus 2 pi over 2 is 3 pi over 2. Sine of 3 pi over 2 is negative 1. 2 times negative 1 is negative 2. Negative 2 plus 3 is positive 1. So it looks like a lot of work, but if you know how to add and stuff like that, that will help you. adding fractions, multiplying fractions, that's where it comes down to. Last is 4x plus pi equals 2 pi. Subtract pi, you get pi. So that's going to be x equals pi over 4. So y equals 2 sine of 4 times pi over 4 plus pi plus 3. 4's cancel out. Pi plus pi is 2 pi. Sine of 2 pi is 0. 0 times 2 is 0. 0 plus 3 is 3. Okay. So let's graph this. Okay, so I have negative pi over 8, negative pi over 2, 0, pi over 8, and pi over 4. Oh, I'm sorry, this was supposed to be negative pi over 4. Okay. X values here. Don't worry, mistakes are only opportunities to learn. So I saw something look weird because they're somewhat symmetric. You should have the same x values on either side, especially with that. So that's how I was able to see, okay, well, something's wrong there. 0, pi over 8, pi over 4. Okay, so we're going from 0 to 5. So we have 1, 2, 3, 4, 5. So we have negative pi over 4, 3. Negative pi over 8, 5. 0 is 3. Pi over 8, 1. And pi over 4, 3. If you were asked to do more than one cycle, you would keep going. I'm just going to do 2 cycles for you. So just you're adding pi over 8 to each number. So you're going to have pi over 4. So pi over 4 plus pi over 8. Okay, so that's going to be multiplied by 2 and 2. So that's going to be 2. 2 plus pi over 8 is 3 pi over 8. 3 pi over 8 plus pi over 8 is going to be 4 pi over 8, which is pi over 2. And if you can remember, that's 4 pi over 8 plus pi over 8 is 5 pi over 8. Okay, so sometimes it might help to remember what you put here, because that was 4 pi over 8. It'll make adding it a lot easier. Okay, so just follow the trail right here. So it's going to go up, down, here, and then the next one is going to be, that's 5, I believe. 5 pi over 8 plus pi over 8 is 6 pi over 8, so that's going to be 3 pi over 2, I think. No, 5 pi, so 6 pi over 8. So divided by 2 on both sides, you're going to get 3 pi over 4. So there's 2 cycles right there. Okay, so that's how you graph a function with a phase shift. Okay, let's do cosecant. Will work relatively the same way. So that should be able to conclude, unless y'all want me to do a cosecant. I'll do a cosecant for you. Or we'll do a secant, because that one starts at negative pi over 2. Okay. So let's just do, make it somewhat easy. We'll do secant of x plus pi over 2. I'll do minus pi over 2 because we did a left shift. Okay, so remember, secant is, the period is 2 pi, my amplitude is 1, My period is going to be 2 pi over 1, which is going to be 2 pi. My phase shift is going to be pi over 2 divided by 1, which is pi over 2, and I have no vertical shift. So secant, you start at negative pi over 2. X minus pi over 2 equals negative pi over 2. So that's going to give me 0. Okay, and anywhere, so for secant, anywhere where you have a, let's see, is that, yeah, anywhere you have a pi over 2, that is where you're going, that is where you're going to have a vertical asymptote, okay? So, let me get this plugged in, my battery's about to die. Okay, so go ahead and plug those numbers in. Okay. Zero minus pi over 2. Okay, so that's where we wanted to start. So pi over 2 here is going to be a vertical asymptote. Okay. Next point is 0. So y equals secant pi over 2 minus pi over 2. Secant of 0 is 1. X minus pi over 2 equals pi over 2. It's going to be a vertical asymptote. So that's going to be 2 pi over 2. So that's going to be pi. Y equals secant of pi, which is going to be 2 pi over 2, minus pi over 2. So that's going to turn into pi over 2 here. Secant of pi over 2 is a vertical asymptote. X minus pi over 2 equals, let's see, we got negative 0, pi over 2 pi. So 2 pi over 2 plus pi over 2 is going to give you 3 pi over 2. Y equals secant of 3 pi over 2 minus pi over 2. So 3 minus 1 is 2. 2 pi over 2 is 1. So secant of pi is negative 1. Last one. X minus pi over 2 equals 3 pi over 2. Add pi over 2 to both sides, you get 4 pi over 2, so x equals 2 pi. Y equals secant of 2 pi or 4 pi over 2. Since you're subtracting from pi over 2, go ahead and convert it. 3 pi over 2, which is a vertical asymptote. Okay, so our first point is 0 and a vertical asymptote. So let's go ahead and draw that. Okay, pi over 2 is 1. Pi is a vertical asymptote. Alright, and then you have 3 pi over 2, which is going to be negative 1. And then you have 2 pi, which is a vertical asymptote. Okay, remember, you can't go this way. It's always like either this or that. Okay. Okay, and that concludes our work on graphs. So I hope this was able to help you. Just a quick reminder, tangent and cotangent have a period of, yes, let's go over that. So if you have y equals a tangent bx minus c plus d. A is still the amplitude, but the only difference is the period is going to change. To find the period for a tangent or a cotangent, that's pi over b. That's how you find that. Okay, so that's the only difference. Okay, so I hope that was helpful, and y'all have a great day. Thank you for listening.